Hello and welcome back. In this video, we're going to be working through the challenges that make up the second boss battle, which is the Catacombs of the class. I don't think we're going to get through all of them in this one video because there's quite a few. You scroll down here. It starts here with the point and includes all the way through tic-tac-toe. There's 9 different challenges there. And this whole bundle of challenges, the whole purpose is to get you more familiar, comfortable with making classes and getting started on your object-oriented design journey. I do want to warn you, this whole series of challenges, it's a tough challenge. It's supposed to be hard. It's supposed to push you. Object-oriented design is a complex skill. You don't learn it overnight, and you really won't learn it if you don't start making some programs. So there's rules of thumbs that you can learn and follow, but a lot of it just needs to come from just hands-on experience and practice, just getting your hands dirty and just trying out stuff and seeing, well, this thing worked and that thing didn't, so I'm going to do more of this next time and less of that. Your first attempt at this stuff, it's going to feel awkward. Your second attempt, it's going to be a little less awkward. After you do it a few dozen, maybe a few hundred times, it's going to start to come more naturally, more easily. So I do want to say that when it comes to design, you should expect some pretty big differences between your code and mine. Don't feel bad if you came up with a different solution than mine. Different doesn't mean worse. Just take the parts of my code that you like and use it in the future, and anything you don't like, ignore it. So I don't know that we're going to get through all of the challenges. I don't know that we're going to get through tic-tac-toe in this video, but we're going to get started and we'll just see how far we get. So with that, let's get started. So the first 5 challenges here are going to ask us to basically to just make a single class and show that it works. So these first 5 challenges, the point, the color, the card, the locked door, and the password validator, are all about just, we're going to make a class that does something, and then we're going to just write enough code to make sure that it seems like it's working. So I'm going to jump over now to some code over here. I've already started making a project. I will finish this, create. Give it a second. All right, here we go. So I'm going to copy over some of the objectives from the first one, the point. And let's just go ahead and get started. So this wants us to make a point class with properties for X and Y. Let's see, the first question I have here, and I didn't read, maybe I need to come back here and read it. Does this say whether these should be integer or floating point things? I don't, at a glance, I don't see anything here that says one way or another if these should be integers or floating point things. So I think you could go either way on it. I don't think it's wrong if you pick the opposite of what I'm about to pick here, but I think for extra flexibility, a point to me sounds like something that deserves to be floating point. So I think that's what we're going to roll with here. So define a new point class with properties for X and Y. So public class point. So I'll start my class with just a simple, class definition, and then I'm going to add in properties for X and Y. Public. Like I said, I'm going to go with a floating point type. I'm going to use float. I could use double. For most situations where you might use, a point, a float is probably big enough. Again, I don't think a double is wrong here, nor do I think like an int is wrong here. There's nothing about this that seems to dictate that it must be a floating point type. I just happen to have chosen it. Public float X. Now I could make this just it's got a public getter and a public setter, and I could do public float Y get set. So I got 2 properties here with public getters and setters. I think the big question in my mind is, should these be immutable? Should we make these not have a setter or something like that? I don't think this challenge dictates that it needs to be settable, but it also, I don't think it looks like it. There's an answer. Answer this question: are they immutable? Why did you choose what you did? So far they are not immutable. They are mutable, and the reason why I did that so far is just a coincidence. It's just what came out. So let's stop and think about it and actually answer that question. In this case, there's nothing that decrees that it should be changeable after the fact. And so there isn't like a compelling reason in terms of like requirements. There isn't something out here that says it needs to be this or it needs to be that, or here's the reason, like it needs to be capable of doing this thing. So it comes down to just kind of our gut feel of what do we think it ought to be. And I think for me, if it's at all possible to make something immutable, I will usually prefer that. There's a lot of complex reasons for it, but mostly it comes down to it's really easy. If you know the thing can't change, uh, it's really easy to reason about it and think about it because you know it'll never change as time goes on. And that's actually a really nice thing. It means, for example, I could like pull the x value off of the point and remember it, like cache it in another variable and know that the point isn't changing behind the scenes. So that's a pretty compelling reason to make this immutable unless there's a good reason not to. And so I mean, that maybe is a reason to leave this the way it is now. But another reason is it's just less code. I didn't have to have a setter. It's just got a getter. So that's another good reason for this to just be immutable and not have a setter. Now, if there was a compelling reason to add in setters, we could do that. There's nothing like bad about making it mutable and adding in setters, but I think I'll treat this little discussion here as an answer to that question. But that's my reason and why I'm going to go with immutable. It doesn't have to be. I think it could be a totally legitimate reason to say, well, I made it mutable, I made setters, because I think I might want to make them changeable later. I think that's a good reason to make it mutable, to make it changeable. So we're also done with this one. Define a new point class with properties for X and Y. So I think I'm going to check that one off too. So the next thing here is add a constructor to create a point from a specific X and Y coordinate. So now we make a constructor and we're going to pass in parameters for X and Y so that you can create it with a specific X and Y coordinate. And now we have to get these values that are passed in into our properties here. So there, we assign this X parameter to the X property and the Y parameter to the Y property. One thing that's notable about this is we don't have a set, yet we are able to set a value. The way this is set up, we are only able to set a value in a constructor. If we made another method down here, we wouldn't be able to do this from another method. All right, so I think we can check off that one. And now add a parameterless constructor to create a point at the origin. So we want another constructor that has no parameters and just starts it at 0, 0. So a simple way we could do this is public point. So there's our parameterless constructor. We could just say x equals 0, y equals 0. And I think that checks the box for that. So now we can create a new point using this constructor that's just at 0, 0, or we can create one at a specific location. Now, in your main method, create a point at 2, 3, and another at -4, 0. Display these points in the console window in the format x, y to illustrate that the class works. So I'm going to make my main method right here So I'm going to make a new variable point, p equals new point at 2, 3. So I call my constructor here with 2, 2, and 3, which we'll call this constructor. And another, so let's call this P1. And another one called P2 at -4 and 0. Display these points on the console window. So we could do something like console.writeLine, and we can do string interpolation here, p1.x, p1y, and then do the same thing for p2. I'm going to run this now, and I think that should get us what we need. That looks like it is displaying it in the right format, and it looks like everything seems to be working. We got a 2 and a 3 and a -4 and a 0. This also seems like the kind of thing where we could maybe make a method to display this. So we could do something like void display point, pass in a point, and then just put this code in here. Now our variable is called p, not p2. So display point, we pass in the point, and now we could just call display point p1, display point p2. So now we have a method that can display any point that we give it anywhere. Let's run that again and make sure that we are still getting the same result. It looks like we are. Of course, at this point, maybe we don't even need to put if this is all we're doing with it, maybe we don't even need to store it in a variable. Maybe we can just do this kind of thing. It has one more variation on the idea. So I think that checks off all of the boxes for the point challenge. I think we can call that one done. So I'm going to delete this code and let's move on to the next challenge, which is the color. I'm going to copy this into here. So we got our checklist again. So define a new color class with properties for its red, green, and blue channel. So this is a lot like what we just did with the point. And we're just going to make a public class color. And now we need properties for red, green, and blue channels. Again, this doesn't specifically say what type to use for these red, green, and blue channels. So we get a pick. We got freedom. Given the little drawing in the book, go back to that. Given the drawing, like these are values from 0 to 255. 255 is all the way up. You know, white is 100%. Like all these are up to 255. Each channel can be from 0 to 255. So this doesn't specifically say what type to use, but this sure feels like a compelling case for a byte. It's not a coincidence that this is 0 to 255. So I'm going to use a byte. If you happen to use an int or something else, I think you are just fine. But I'm going to say public byte R. And for same reasons as we talked about with the earlier one with the point, I'm going to make this just a get only property, so it's immutable. And I'm going to make a G and a B. And so we got RGB color. Add appropriate constructors you feel make sense for creating new color objects. So I think it makes sense to have one So again, this gives us a bunch of freedom in terms of what we do. And for me, I think, oh, that was nice. I was able to suggest all of those. So for me, I think it makes sense to have a constructor that allows us to pass in specific values for red, green, and blue. I don't know if we necessarily need a constructor that's like a parameterless one like we had with the point. But one thing that I think might be kind of nice is to have one that, well, now I'm thinking this through a little more. Maybe that's good enough. I was gonna say maybe we make one that has an int values here, because very often people will be using ints and then just cast it to a byte. So maybe that's a possibility as well. I'm going to leave this in here for a minute, just because this makes it easy to do something like new color 25, 42, 88, 99. My finger's on the wrong key, but it doesn't matter. 99 is as good as 88. Like, it makes it really easy to do that in code, but the reality is that even without this, we actually still get that. These are literals, and the compiler is willing to say, look, they're int literals, except for they are within the range of a byte. So I'm willing to call this constructor with bytes like that. So it depends on how much you think your program is going to use ints versus bytes. If you end up having to do a whole lot of stuff like this everywhere in all your code, because you've got things like this, int red equals 25. If you've got a lot of stuff like that in your code, red, got to spell that out. If you got a lot of stuff like this where you're constantly casting, then it might make sense to have another constructor with int values that just casts it for you. If you don't have a lot of that, then it probably doesn't matter. All right, so for me, I think this is I don't know that we need another constructor. Somebody might want to get clever here and do something like, what if we passed in like a hex code? I don't know that we really have the tools yet to like really do a lot of parsing on that. The book does cover that when it gets to files and reading data from files a bit later on, but we could do something like that and allow us to say something like new color and then do something like A20030. Like, we could make a constructor that does that. That could make logical sense, but like I said, we don't have the tools for that right now. So I mean, you could probably figure out a way to like access these and like add and multiply and things like that. So you could do it, but I don't think it's strictly necessary at this point. So I'm going to leave that out. So I think we've added all the constructors that make sense right now. So let's move on. Create static properties to define the 8 commonly used colors for easy access. I'm going to put this over on my other screen that you can't see so that I have easy access to it. Create static properties. So this wants us to use static here that's not the first time, but public. So a static property could look like this: public static color white. So this is a property. We've got the get, and we know it's static because it's got the static keyword on it. So when we make this, and I haven't assigned this a value, so right now this is going to be null, and this compiler warning is complaining about that. We'll fix that in a minute. But now we can do something like color favorite equals color.white. And this would presumably get us an instance of the color class that's white. So that's the advantage of this, is this gives us the option to use a handful of instances kind of by name instead of having to like go in and the alternative would be, having to write it out, which isn't too bad, but I like being able to have a handful of these by name that we can just easily get access to. So the only thing that we're missing here is this doesn't actually have a value assigned to it yet. So we can do that here. So now this is a property that when the class gets initialized, it's going to get assigned this instance, new color, 255, 255, 255. So now anytime after this, whenever you ask for this white, you will get this same instance over and over again. And now we wouldn't need to do that. All right, so that's our first one. The others are all just going to look the same, just with different numbers in here. Let's see. So red will be 255.00. Orange 255.165.0. Yellow is 255.255.0. Green is 0.128. I'm getting all these numbers straight out of the book. Blue is 0.255, and purple is 128.0.128. There. So now let's see, create static properties to define the 8 commonly used colors for easy access. In your main method, make 2 colored type variables. There's 2 color type variables. Use a constructor to create a color instance and use a static property for the other. Display each of their red, green, and blue channel values. So new color. I'm doing these in the reverse order of what it says, but I think it's still. So that's going to, let's see. White is 255s all the way across. Black is zeros all the way across. This, since the red, green, and blues are all the same, we're going to get like a gray color. That's going to be a lot closer to black than white. So kind of a dark gray with those 42s. And now display each of their red, green, and blue channels. So kind of like what we did with the point, I'm just going to do console.writeLine, and then I'm going to do string interpolation and do something like C1.R, C1.G, C1.B, surrounded by parentheses. And then we'll do the same thing for color 2. Run that. Make sure we get values we were expecting. It looks like we did. All right, so there's one thing I wanted to mention here, and that is, in this case, there is actually a pretty compelling reason. The way this is all set up, there's a pretty compelling reason to not let these be mutable, to make these immutable. And that is this. I can do, suppose they were changeable. The thing that this allows now is for me to say C1 equals color.white, C1.R equals 0, C1.G equals 0, C1.B equals 0. So I just set C1's R, G, and B values to 0. However, this is referencing the object that is stored in white. And what that means now is that same instance that's in here just got changed. So now if I do C2 equals color.white, well, now I have a problem. Let me run this and you'll see what I mean. Oh, I didn't mean that to be a 2. I meant it to be a 0. Though even that illustrated the point, I think. So 0, 0, 0. Like we just said, get me white, and white has been permanently changed, redefined to basically black, to 0, 0, 0. And that's because it's mutable. It can change over time. So this is one of those reasons why maybe immutability, if you can achieve it, if it makes sense for what you're doing, is something to prefer when possible. It avoids situations like that where what we had changed. Now there is a way around this. We could allow these to be basically factory methods, factory properties. And we could, every time somebody asks for white, we could just create a new color instance that happens to be white. And a way to do that is, so we could come in here and we could say, return new, bring this in here, return new color. So now this will say, every time we call this getter, we're going to create a new instance. Now, if we run this, you'll see that when we call, we did change this original one, but the second time we call color.white, we get a new copy, a new instance that happens to be white still. So that could be a way around this. We could allow ourselves to change these colors while still ensuring that each of these properties are, they keep returning what we expect them to anytime anybody asks. Although if we're going to do this, there is a shortcut. Use expression body for properties. So that now this will just, the getter will just return a new color. It still does the same thing. This still returns a new instance. So we could do that instead. That's pretty easy to do. This would mean that every time we ask for these properties, we're getting new instances. And in the general case, I think, in my mind at least, when I'm calling a property, I'm not thinking of creating new stuff, just telling me what's there. So I wouldn't, like, this feels just a little bit wrong. And another way around that could be something like, instead of having a static property, we could have like a method instead, which in my mind at least doesn't have quite the same connotation of, it's just going to give me a value that is a part of the thing already. So we could do something like this. And now it's not a static property, but a static method. And now in this case, we can say color.create. Now it makes sense that these are going to create it. They're like, by name, create white. They're going to create something. They're going to create a new instance. So now that becomes a factory method that is an alternative way to get a hold of new color instances in addition to the constructor here. But to be able to get new color instances that look a certain way coming out of the factory. And that doesn't mean they can't be changed after the fact, because they could be. Anyway, so that is a way that you could create. That is another variation on this idea. So we could make these be factory methods instead. The challenge does specifically say create static properties. I don't think I'd get too hung up on that if you prefer this style and having static methods, static factory methods for these. That works just as well too. All right, let's move on to the next challenge. I'm going to delete all of this again and move on to the card. And sorry about that. I'm just getting this text. They're ready to go. So we want to make a class that represents a card, and each card, like normal playing cards, they've got different, like, oh man, my suits. That's what they're normally call this, a suit. These are colors. You got colors and ranks, and the ranks are 1 through 10, and then symbols, $, percent, caret, ampersand, and then the colors are red, green, blue, and yellow. So this kind of points us down the path of we should make enumerations for both of those. So I'm going to come down here and say public enum color, and I'm going to do red, green, blue. Ow. alpha, yellow. And then I'm going to do public. Every time this stuff happens, I always take note of what this IntelliSense is suggesting. Color 4, green, blue. I think that's an interesting. I wonder how it came up with that. But I don't want that. I want public enum rank, and then my choices here are 1 through 10, followed by those symbols. So the interesting thing about this is there's a natural inclination to see numbers 1 through 10 and to say, well, why do I want a number in here? I want this to be 1 and 2 and 3, but we can't do that. So if we're going to have an enumeration, we need to like name off the value, and we can't just use 1 for that. So we could write it out: 1, 2, 3, green, blue, 3, 4, 5, 6, 7, 8, 9, 10. And then the symbols. So again, we can't just put in a symbol like that, but we could do $, %, caret, ampersand. So that is a way to capture this enumeration, 1 through 10, and then those 4 symbols. I've seen people solve this by saying, well, I'm not going to do an enumeration. I'm going to use characters. And I'm just going to make a separate thing, and I'm just going to use the character 1 and the character 2 and the character $. I think if that's the path that you've taken, I think you're just fine. This is more, I think, what I had in mind when I designed the challenge. But I think there's a lot of ways you could do it that are fine. Like I said, it does call out creating enumerations for these. So I think that enumeration looks something like this. If you don't want to write out those, like you could just preface this with like rank 1, rank 2, or something. Like you could do something like that, or R1. But the thing I like about just having this is that it's something that we'll see in a second, is just how it displays it. So let's see. Define a card class to represent a card with a color and a rank as described above. So in this case, we just make a card, and then what we need is a public color. So again, that question of should this be immutable or not, I think once a card exists, like in the real world, cards don't change their suit or their rank over time. So it makes sense in my mind to make these immutable and just get only. And then this doesn't specifically call it out, but I think we're going to need, I think it makes sense to have a constructor. So I'm going to add that in here. So now I can make a card of a specific color and rank, and add properties or method. Oh, define a card class to represent a color. Yeah, so I think we can check off that one. Add properties or methods that tell you if a card is a number or symbol card, equivalent of a face card. So we'll do, it gives us the choice, a property or a method. I think I'm gonna go with a property is number. And then I'm gonna say, so I'm gonna cheat just a little bit here. Rank is less than or equal to 10. I think that works. Oh, I need a return value. Bool. Sorry, rank.10. there's a lot going on here. These two little, it looks like arrows pointing at rank. This is the expression body, and this is the less than or equal. And if it helps anybody make sense of this, maybe we can do, let me just do it this way. A little bit of reworking here to avoid a little confusion. Return that. All right. So these are numerical and they're in order, and therefore we are able to use this less than or equal thing since there is a definite ordering here. So if the rank, if the card's rank, if my rank is less than or equal to rank.10, it's a number. So if it's any of these up through 10 and including 10, then it's there. Now, the book doesn't actually cover that. So if we want to use only, or it might, it just cover, if it just says it briefly in passing that you can use the less than operators on it. So if we didn't remember that, then another option would be to do something like we could just make a switch in here, and we could do something like rank switch 1. Well, actually, let's do there are fewer so dollar, we do rank dot dollar sign is number false. All right, and we can do the other 4 here, dot caret. What are they? Percent and dollar sign. And then for everything else, we can do true. Return is number. I already, dollar sign, caret, percent. What am I missing? Ampersand. So we could do that. I can also, if we're going to do that, we could also just make this simpler and just say return that rather than storing it in a variable. That makes the code a little simpler. I could have, of course, inverted this and named if it's rank dot 1 arrow true, return true. So we could have done that if we had wanted to. Though, like I said, I think I'm going to put this back to return rank is less than or equal to rank dot 10. And then we can also have a method in here for is, what is this? What are we, if a card is a number or a symbol card. So is symbol. And I'm going to take a shortcut here and just say return not the opposite, not is number, because it'll either be a number or it'll be a symbol. So we can just call that method and then just do a Boolean not operator there to just invert it. If it's a number, then if this returns true, we want this to return false. If this returns false, we want this to return true. So that'll just flip it. And I am actually going to use, I'm a big fan of these expression bodies. So I started with a property, I've ended with a method, and I'm okay with that. So I think we can check that off. Create a main method that will create a card instance for the whole deck, every color with every rank, and display each. The red ampersand, the blue 7. So there's a lot of ways we could go about this. And so we could say there's 4 times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. We could do, whatever 14 times 4 is, let's see, 28, 56, I think. We could say cards equals new card 56. And we could do this the brute force way. Cards at index 0 is new card color dot red rank dot 1. Cards at index 1 is the red 2. So we could do this. It's just going to be a lot of code. So we could get clever here and say, is there a way to just loop through all of these? And the answer, of course, anytime you start to see repetition, that you can always do code changes to get it to, loops to be less code. It's just a question of can you come up with a way to express what you're doing as a loop, which is not always easy. Sometimes that's a very challenging thing to do. I'm actually going to take a little bit of a shortcut here and do this. I'm going to say for int color number equals 0, color number is less than 4, for int rank number equals 0, rank number is less than, we had 14 of those. And then I'm going to say card equals new card. And I'm going to take the color number, I'm going to cast it to a color. And I'm going to take the rank number and I'm going to cast it to a rank. And now I have my card instance. And all this needs us to do is like display that. So what I think we can do here is do console.writeLine the card.color card.rank. So the red, whatever. The red one, the red ampersand. I'm not putting this in an array right now. We could do that. But I actually think with what we've got here, we can check this off without putting it in an array. So let's run this and make sure. So the red 1, the red 2, the red 3, the yellow $sign. So that was a convenient way to do this, but I do know for a fact that I've seen a lot of people struggle with this just because of little nuances. And one of them is, for example, that notion of, well, how do I get these into an array? One possibility is this. We could do card, make it like a 2-dimensional array, and make this a 4x14 array. And now we could do something like this. Cards at, let's see, color number and rank number equals that. And now we can just say something like for, I'm going to kind of copy this code here. So now we have a 2-dimensional array of all the cards. So it's in a little grid. And now we can do, oh, and now I've lost my, that's all right. I can recreate it. Let me just go back. I've lost my output. So console.writeLine the cards, color number, rank number, dot color Well, I made a mistake there, but I want to show you the blue card, the red card, the green card. That's because I messed up right here on this needs dot rank. Now it should work. Okay, so now we've got an array, now we've got a 2-dimensional array that has it. But what if we wanted this to be a 1-dimensional array? Well, we can do that. but now we just need to basically instead of like wrapping around to the next row for the next color, we need to just keep going. So what we need to do is compute a single index based on the fact that we've got a particular color number and rank number. So for color number 0, which is what, red? For color number 0, that's gonna, the red 1 is going to be at index 0. The red 2 is going to be at index 1. Red 3 is going to be at index 2. The red 4 is going to be at index 3. So this will be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And then we start over. So the green one is going to be at 14. 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. And then the blue one is going to be at 28. And I don't know if you picked up on that pattern, but this starts at 0. This is 14. That's the number of ranks we have. This is 28. So after the second, by the time we get to the third one, we're starting at 28. So this math is not, so we can do color number times 14 plus the rank number. And that should fill the whole array with the cards that we're doing. Like I said, that's a very common paradigm, but it does take some, like, once you have learned this pattern of like managing like what could have been a 2-dimensional array and squishing it into a single dimensional array, the math isn't too hard, but it does take a little bit of getting used to before that feels just obvious how that should work. But now at this point I can turn this into a for each card in cards. And now this part here gets simpler because I can just do that. So now I can just iterate through the whole loop. Pretty easy. So that made that code, by changing this to a 1-dimensional array, this code got a whole lot easier. And there's some advantages to that too. Like imagine you want to like shuffle the deck. Shuffling a deck of a 1-dimensional like array of cards is easier to work with than something that is like in this case, it starts to feel like just like this like stack of cards, this pile of cards that are in a particular order. So that approach does make a certain amount of sense. Like I said, we're deep in territory of didn't need to do all this, but here we are. The other thing that I see people have trouble with is this, especially if they are using the old, the traditional approach, and you've got a public, so let's suppose you've got something like this: public static, hang on, I'm getting ahead of myself here, namespace cards, and then class program, public static void main string args. And this now goes in here, and this goes here. All right. So suppose you wrote your code like this. This is going to do something interesting, I think. We'll see. Oh, it didn't. It didn't. I'm a little surprised. What I was expecting it to do is actually print out the namespace for this, because I see people have that all the time, where they like what they'll get is cards dot rank dot color or something like that. And now I'm not, off the top of my head, I'm not sure how they are getting that, but I've seen it before. And if you're getting something like that, where it says the cards dot color dot red or something like that, and maybe it's because all of this is in the same namespace. I don't know if that's the case. I want to try one more thing before writing this off. Yeah, it's still not doing it. All right, one more thing that I want to try. I don't think this is the case, but we'd make this be .NET 5 instead. That has taken its precious time to build. Anyway, I'm wondering if this is a recent change that I just missed. Okay. Feature global using directive. Yeah, okay. If I'm going to change that, I need to also change one other thing in here. Oh, I didn't do it there either. So I know I have seen people who have ran into that situation. So I wasn't expecting the changes I just did to have an impact on it, but I'm not sure how. I'm not sure how people are running into that. But I've seen the code and I know I've seen that happen. Like I know it's a thing. I'm gonna undo quite a bit here. So suppose that like for whatever reason you do like you have an enumeration and it's not getting you the text that you would have normally wanted. One solution, one workaround for that could of course be something like let's just make a string and just do something to like convert from one to the other. So something like return color switch. So if it's red, return. If it's a color.red, so you could do something like this if you wanted to. If you're not getting it, if the text is, what am I doing? Yellow. You could do something like that. And in fact, for that matter, like if you wanted to, you could do probably the more interesting one here would have actually been this rank. Like we could have if you didn't want to use that text. Just make another one here. Convert to string. Convert color to string and convert rank to string. So like you could do something like this if you want to fine tune the output. This is obviously more code, but it does give you more flexibility. And there's so ampersand. I'm gonna stop here because I think you guys get the point. And I don't want to go on forever, but there. And now we just have to call these. And now you can see the ones we actually handled, they are showing different stuff. This would also, if you need to be able to like translate it to different languages, like if you want to make these French, you could do that. That's something that I've mentioned to a lot of people over time, is to just literally display the enum value doesn't always make sense, because a lot of times what's displayed in the user interface, including a command line interface, may not be, you may not want to like show like the names of code elements, because that's normal. That's what you're actually getting here, is names of code elements displayed on the screen. So something like this $sign is going to look a little weird to people, because it's like it's written like it would be written in code. And that's probably not always what you want. So it like this type of thing, even though it's more work, is sometimes more correct anyway, because it allows you to do something like rank $sign and to say $sign with a space. Or like I said, you could do translations, or there's like this type of thing to convert from the code representation to what gets displayed on the screen. There's a lot of reasons to do it that way. And now it might read more natural than having like $sign all as one word. Anyway, we've spent way too much time on this challenge. I'm going to check that one off. I think we've been there and covered a whole lot of variations. Let's answer this question and get done with this. So answer the question, what do you think? Why do you think we used a color enumeration here but made a color class in the previous challenge? My answer to that is, in this context, so it depends on the context. In this context, there are 4 choices for colors: red, green, blue, and yellow. That's it. And because it's a small, very definite list of options, and enumeration is a good fit. The color class that we made before is meant to represent literally any color, and or at least any color where you have a red, green, and blue with different channels. But that would be like 255 times 255 times 255 possible choices, and you would never want to, like, an enumeration with that many choices is not something you'd actually want to do. So in that case, you're trying to represent yes, they're both colors, but as far as the code understands it, or even as a human thinks of it, like color in this is like part of like a card game, and it's a very limited set of choices, versus color in the other one where there's like the little picture had like a little slider, and like it could be literally any color, which is a very wide open thing. So we could have done this color in as a class without too much trouble. We could have done the other color class in the previous challenge as an enumeration with a whole lot of pain, because we would have had to write out all possible combinations, which is way too many to actually want to do that on. Anyway, that's the reason why, is it depends on the context, and that context deserved a class with multiple values. This context just needs an enumeration. So that's the reason for that. We've been going for quite a while here, but I kind of want to just keep going. So I'm going to move on to the door class. So let's give me just a second to rework some stuff here, and then we will move on. All right, I'm going to delete this. And so this is the door class that can keep track of whether it's locked, open, or closed, make it so you can perform 4 transitions defined above with methods, build a constructor that requires the starting numeric passcode. Well, and let me, so we, there's all these states in here. An open door can always be closed. A closed but not locked door can be opened. A closed door a closed door can always be locked. A locked door can be unlocked, but needs a passcode. And a door is created, it needs to be given an initial passcode. And you should be able to change the passcode. So this, like, here's a class that like has some logic to it. Like, it represents a door that could be locked. And by the way, we're going to have a passcode, and it's going to be like an int or something like that. This is not somebody who's trying to hack. Like, this isn't secure. Somebody who is trying to hack this would probably not have a hard time reaching in there and seeing like that number that's in there. But for a lot of other, so from a purely security standpoint, this is not super duper secure. But the concept is what we're going for here, is a door class that it works a certain way. There's logic to it, as opposed to all the other things we've been doing so far in this Catacombs of the class boss battle, where they've all been like data centric types. This is one that finally has some behavior. So we're going to make a class door that can keep track of whether it's locked, open, or closed. Now, to me, that sounds like an enumeration. This doesn't specifically call that out, but when we first started doing enumerations, we actually had a similar thing. So I'm just going to make a door state locked, open, closed. And then I'm going to have in here public. Well, okay. Well, I'll just start with this. Public door state. And let's see. Does this say what how it's supposed to start? It doesn't specifically say what state this should begin in. I'm gonna start it in the closed but not locked state. So now we've got a door that, now here's the catch. With the way this is, the state is settable. If it's locked, I could just set it to open and it would be open. And so that's not really the paradigm we want. So I think we want, if anything, we want a private setter, because I know like it is going to change over time. We already know that. But it's, so we do need it to be settable somehow. And this is a pretty good way to do that, I think, is we just make it settable but private. So we'll only be able to change the state from within this class. So I come up here and say, new door. I won't be able to do that. That won't compile. So I'll make sure that none of my code accidentally opens a door without unlocking it first. So define a door class that keeps track of whether it's locked, open, or closed. Make it so you can perform the 4 transitions defined above. So an open door can always be closed. A closed but not locked door can always be opened. A closed door can always be unlocked. A locked door can be unlocked, but a numeric passcode is needed. So since we're making this private, we do need some way to ask the class to change its state, ask the door to change its state. I'm going to use methods for that. So public void open. Now, so if the door is open and if the current state is open and we call open, I think that's fine. No, I mean, it's open and it stays open. If it's closed and we say open, then going to the open state is fine. So the only state that we would have problems is if it's locked. So if state equals door state dot locked, return. So I'm going to say state. So I kind of have done this backwards. Let me start over. So we're going to say state equals door state dot open. So now somebody can call open and it will just set it, using the private setter, it will just set it to open. The problem though, of course, with that is that I can just say door dot open. And even if it was locked, I would still, that would still open it. So if I put this line in here, so this is the only state where I should be able to just open it. If it's open and I set it to open, it's not going to hurt anything. It doesn't change anything. If it's closed and I say open, we want it to actually change. It's only this locked state that's problematic. So maybe that's let's keep going down this path and we'll just see where that goes. But that seems like an okay way to do it. So public void, the next one is closed, but an open door can always be closed. I'm actually doing these out of order. Public void close. If state, so an open door can always be closed. If state is open, state equals door state dot closed. So I said, let's just run with this and see where it goes. Now that I see this code, I like this approach better. This says like if we're in a closed state, if we are currently open and we're asked to close, we're going to set it to closed. I like that approach better than what we've got here. So I'm going to change it. So if state is, so a closed but not locked door, if state is closed, state equals door state dot open. So I like that better, and I like the symmetry here. I like that these match. A locked door can be unlocked. Sorry, a closed door can always be locked. So we could do public void lock if state equals door state dot closed, state equals door state dot locked. So if we're in the closed state and we command it to lock, then we do it. And now the last one, public void unlock. So a locked door can be unlocked, but a numeric passcode is needed, and the door will only unlock if the code supplied matches the door's current passcode. So when we unlock, we need to supply a code. So I'm gonna use an int for that. Like there's a lot, like we could do a lot of things for this. It could be a string, it could be a character. Oh, it does say a numeric passcode, so a character probably wouldn't make sense. Depending on what range we want, that could be a short, or maybe we want it to be a 4-digit passcode, and we could pass in like an array of digits or something. Like there's a lot of things we could do, but I'm just gonna keep this simple and just say it says the challenge description says numeric, so I'm gonna make it an int. So if state is door state dot locked, state equals door state dot closed, but I haven't checked the code yet. So if it's locked, then we should if it's locked and the code equals, let's call it current code, and I need to come up here and add in a private int current code. I'm just for the moment, I'm just going to set this to 0. So if state is locked and the code matches, so if we're in the locked state and we've provided the correct code, then change it to closed. Otherwise, this does nothing. All right, let's see. Private int current code equals 0. So I think we can do those 4 transitions, build a constructor that requires the starting numeric passcode. So I actually think at this point I can do, well, we'll put that here, public door initial code, current code equals initial code. At this point, I don't need to assign that to 0. So now I need to supply a code, and we can do 1, 2, 3, 4, the best code in the world. Make a constructor that okay, so I think we're done with that. Build a method that will allow you to change the passcode for an existing door by supplying the current passcode and new passcode. Only change the passcode if the current passcode is correct. So we could have right here, public void change passcode int current int new code. I can't use new here because that's a keyword, but I like making them match. So current code and new code. Could have called them passcode, current passcode and new passcode. If the current code equals current code, so if they have supplied the correct current code, then we are going to say current code equals the new code, or we'll update the code. All right, I think that checks this box. Make your main method ask the user for a starting passcode and create a new door instance. Allow the user to attempt the 4 transitions described above and change the code by typing in text commands. All right, so let's see. We're going to do console.writeLine, enter initial passcode. I'm going to make this right instead of write line. I'm going to do int initial code equals console.read line, wrap that in a convert.to in32. We've done this a million times. And now I make a door. Door equals new door with the initial code. Oops, valid time zone exception. All right, so now we've done the first part of that. Create a new door instance. We've done that part. Allow the user to attempt the forward transitions described above and change the code by typing in text commands. So while true, I'm just gonna let people go forever here. And I'm going to say console.read line. Sorry, write line. And I'm going to do a switch based on the input, and I'm going to have the default case be console.write line. I don't know what that means. So if they enter in anything that isn't one of our specific choices, we're going to say, I don't know what that means. So case open. And I think we can just call door.open. Case close door.close. Case lock door.lock door.lock. Case unlock. So here's where this gets a little tricky. We need to be able to, we're going to do this console.write line. What is the enter passcode? Let's do that. Enter passcode. And then it doesn't specifically say what it would be, but we can say change code. All right. So if we're changing the code, we ask them for the current code, and then we ask them for the new code, and then we call this change passcode. The one thing that I do want to do here is we need to do this. Our door is we need to tell people what state it's in so we can watch what's going on here. I've written a lot of code without running this. That's always a dangerous game to play. So let's see where we ended up at. Initial passcode 1, 2, 3, 4. The door is closed. What now? Open. The door is open. Close. The door is closed. Close. The door is closed. Open. Door is open. Open. Lock. The door is open. So we can't go straight from an open to a locked one. So we can say close. And now we can say lock. Unlock. Enter passcode 5. The door is locked. So because I put in the wrong code, it didn't, like, nothing happened. I didn't change state. So let's try that again. Unlock. Enter passcode 1, 2, 3, 4. The door is closed. So because I entered in the right code, it worked. What now? Lock. Change code. Enter current passcode 0. enter new code, 1. So it, oh, that put it on another line. I got a console.write line when I probably wanted a console.write. But so unlock. Because I didn't enter in the right code here, the passcode is not 1. It's still 1, 2, 3, 4. And that isn't very obvious to the user that we did that it failed. So there's a couple of little changes we can do here. And that is, I'll change that to a right instead of a right line. It would be kind of nice if this returned whether it was changed or not. So let's rearrange this a little bit. Return true, and then down here. So if otherwise we just return false. If we match the code, then we'll change the code and we'll say we changed the code. Otherwise, we return false. And now, right here, we can say we can catch the result, whatever that value is, in a variable. So now, whether it's successful or not is there, and if not success, well, we can do console if success console.write line. The passcode has been changed. Else console.write line invalid passcode. Passcode has not been changed. With that, at least, change code. Now at least it'll tell us invalid passcode. Passcode has not been changed. So at this point, generally speaking, I think we've met all the objectives of this challenge. And I mean, this is a pretty substantial program. Now it's 93 lines of code. We've got this class in here that is from line 50 to line 92. So we got a 42 line class that it's got a bunch of methods and I like it's that long, but also I tend to be pretty concise. Like a lot of other people would do this. Some other people would do this. So where I had 1 line, other people might have 4 lines. So it like there's quite a bit here. Well, there, I just got rid of 1 line. There's quite a bit here. So this is honestly probably not giving you enough experience points for what it is. Because you have to make the class and add in all this logic, but then you also have to like do this sort of code here to like loop and allow them to enter stuff. One thing that I have seen a lot of people do, and I think it's a reasonable thing, is they want this to be a case insensitive thing. And one way to do that is to take the input and to call like 2 lower or 2 upper on it. And by doing that, now if I run this, now I can type in open. The door's now open. Oh, sorry, close. Now it doesn't matter what your capitalization is. I've also seen a lot of people, sorry, I'm stretching there. I've seen a lot of people also like want to put in additional like this type of stuff, but for like all of these. And I think if you want to do that, there's nothing wrong with it. If you do that, then you might want to follow a similar pattern for this change passcode. And return bools for these so that you can tell whether or not it changed state. So you can, I mean, I'll do this for a one bool. So if state equals, then like I said, obviously you can see already this is going to complicate the code, but return true, and down here return false. So now when we open, we can say bool success equals, and then do, we better put that variable out here, success. So that those two branches aren't stepping on each other's toes. If success console.writeLine, that worked. A door is open. Else console.writeLine, that didn't do anything, or something like that. And now we should be able to say open. That worked. The door is open. Open. That didn't do anything. Close. Lock. Open. That didn't do anything. All right. So like that kind of thing gives you that ability to like display more output. And the other thing that I've seen people do, and I don't think this is, I like this approach better than what I'm about to do, but I don't think this is so bad, is they'll come in here and they'll put here console.writeLine. That worked. The door is now open. And then down here, console.writeLine. Nothing happened. And then this can just be void, and you can get rid of the return true and the return false. And now we can just call open. This gets us the exact same behavior. However, so like this is a fine approach, but the problem now is we can't, like, it limits the usability of this door class. Like we can't, for example, we couldn't take this and just stick it in like a game that's got like a whole house with lots and lots of doors everywhere that has lots of things that could trigger a door to open, or you solve a puzzle and a door opens, or I don't know, things like that where one door opens and another door closes automatically because of some trigger in the game, or things like that. Because every time you do, you're going to be getting this output of that worked, the door's now open, when that wasn't really like, it wasn't driven by a human interaction. And these are just side effects of opening the door. So in my mind, it makes more sense to keep this simpler, to go back to the, if you really do want to be able to respond to that, to go back to something like the bool, where we don't put the text, this text here, but keep it back out here. Like I think this is better, because this is like, now this output is a direct, like in this, like this is the context for it. This is happening because we literally just had a human type in the word open and attempted to open the door. And now this text is like closely tied to this. So in my mind, that's a slightly better design, just because it separates like the interaction with the user from like the internal logic of how doors are supposed to work. And I like that. But like I said, doing it the other way, if that's how you did it, because I've seen a lot of people do that kind of thing, I think it's fine that way too. All right, this has been a very long video, and I want to, but we're actually really close to finishing up this first set, and I think I want to keep going a little bit longer. So let's move on to the very last one, which is the password validator, that I actually think is quite a bit easier. Though I guess we'll see. But so this is the first time we've made a class that doesn't like represent something that like feels like a concrete, like colors and cards and doors and all that stuff feel like they've got a very concrete, specific, we can imagine what they look like. In this case, we're making a class that's more philosophical or abstract. Like it isn't a specific thing that you could point to, but it is an object in the system that has a very defined specific role, and that is to validate passwords. So again, public class password validator. And it can be given a password and determine if the password follows the rules above, which are actually below. In this case, I put them right here. Maybe that would be easier to understand if I put them here. Anyway, but these are those rules. So we can do public bool is valid, and then we give it a password. So that's a start. So the password must be at least 6 letters long and no more than 13. Now, I will say, like, these are the types of rules that honestly IT departments and stuff often have. In truth, from a security standpoint, like especially an upper limit is not a wise idea. From a security standpoint, the longer the better. So to limit people to 13 characters is not that great. And frankly, this kind of stuff of at least one uppercase, one lowercase, and one number, that kind of stuff is definitely helpful. But there are also other better solutions to passwords. Like these rules that are in here are not meant to be, these are the ideal rules that you should apply for any password validation anywhere. These are just, here are some random things so that we have some logic to go into our password validator. So don't take these rules too seriously, and I hope that's conveyed a little bit because of this Engelmar and IT thing, decreeing that capital T's and ampersands are bad. So like I said, don't take these as too serious. It's just, here is a challenge to do. Let's make it work. Let's figure it out. So password must be 6 letters long. So if, let's do it this way. If password dot length is less than 6, return false. It's not valid. If password dot length is greater than 13, return false. So I actually think we've checked this one off. These other ones are going to be a little bit more complicated. So passwords must contain at least 1 uppercase letter, 1 lowercase letter, and 1 number. And the book does have a hint in here for us. It says, it gives us this code here. And it gives us this code here as an example. So here's what I'm going to do. So this says it must contain at least 1 uppercase, 1 lowercase, and 1 number. And so this is upper, lower, and a number, a digit. So these things are going to help us, and I think this combination is going to be enough for us to. So what I want to do is I'm just going to total up int uppercase count. I'm going to start it at 0, int lowercase count, and int digit count. So I'm just going to have 3 variables, and we're just going to, for each character in the password, we're just going to, if character dot is upper, the letter, then uppercase plus plus. And we'll do the same thing for lowercase, and the same thing for digits. Just have to change is lower and is digit. So at this point, once we get done with that, we'll be able to check. So if uppercase count equals 0, return false. So we're basically we keep like failing and saying, oh, we didn't pass, and at the end of like so a check if it's less than 6. If not, then we're done. If it's greater than 13, then we're done. If it doesn't have an uppercase character, then we're done. If it doesn't have a lowercase character, we're done. So all these things that we're gonna check each of these rules in sequence, and if we get to the very, very end and haven't found a rule violation, then we know it's valid. So we'll do lowercase count here. And we'll do digit count. So I think now we can check this one off. And it cannot contain a capital T or an ampersand. So there's a couple of ways we could do this. One is we could just add on here, int capital T count equals 0, int ampersand count equals 0. So we could just continue the pattern. If letter equals capital T as a character, capital T count plus plus, and we could do ampersand, and we could say if capital T count equals 0 or ampersand count equals 0, return false. I actually think that is enough to check off all the boxes, and there's some variations on that, but let's come back to that in a minute. Let's do this. Make your main method loop forever asking for passwords. So while true, I'm going to keep this simple, and I'm going to just say console.readLine console. I'm packing a lot into a single line here, but I'm going to write. Well, let's make a password. Make a new password validator. We only actually need one for the whole time. This doesn't remember any state, so there's actually no reason to ever make more than one of these. But yeah, so so we have the validator, and we're gonna do. All right, fine. I'm gonna break this up a little bit. String password equals read line, and then bool is valid equals validator dot is valid. Pass in the password. And then we'll do console.write. If is valid, console.write line that is valid. Else is invalid. I'm putting that in capital letters so that it stands out to me when I run it. So I can type in passwords fast and furious. So this, I didn't have a prompt, so it's just waiting for me to type in something. So let's see. I need an uppercase and a lowercase and a digit, and I need at least 6 characters. Oh. Why is it invalid? I don't know. Well, there's only one thing that we can do here, and that is set a breakpoint and do it again. So I got my breakpoint here, and now we can see what's going on. So password.length is less than 6, return false. Nope, we didn't fail there. I'm gonna tell it to run to here. And now let's look at these. Uppercase count is 1, lowercase count is 7, digit count is 1. Oh, okay, I see. So the place that's biting us here, I can keep stepping through this, and right there. So this should be not equal to 0, and same with this ampersand count. So I'm going to just reset this back up to here and let it run, and it should be valid. Okay. So if we don't have any uppercase letters, it should fail. Oh, I don't need that breakpoint anymore. It should fail. And if we don't have any lowercase letters, it should fail. And if we don't have any digits, it should fail. And if we have a capital T, it should fail. And what was the other one? An ampersand. It should fail. So I will say that it would be kind of convenient for this to tell you why it failed. The challenge doesn't call that out. Like, you don't need to do that. But it would definitely be convenient. So let's suppose we did want to add that. Like, we could do, and we just talked about this in the last challenge, we could do something like console.writeLine password must contain an uppercase letter. And we could do that kind of thing for all of them. And I'm going to just run this again, and we'll do that again. So AA3 query. Password must contain an uppercase letter. That is invalid. So like if we did that for each of these failure modes in here, then we could have, it'd be able to tell us which of these failed. And that would be really convenient, because then, well, I guess I didn't realize that I needed an uppercase letter. And now I do. So now I'll go add in an uppercase letter. Again, like before, it feels a little strange. Like I don't love that this guy is like literally writing to the console window, because what if we picked up this password validator and moved it to a web application or a desktop application, or embedded in Unity? Like, this console.writeLine is sending that information to the wrong place. So it'd be better if there was a way to like convey that information instead. And maybe a way to do that is instead of returning a bool, we can have like we can do something like this: public enum validation result. Well, success. I like that. It suggested success and error. But and then we could do too short, too long, needs upper case, something like that. And then we could just change this to be like a validation result. And then here we'd return validation result dot too short. Like, all the reasons that this could fail, we could put into this enumeration: too long. And then down here, instead of this could say return validation result dot needs uppercase. And we do the same thing for these, but I'm going to skip them for the moment. And then down here, this can say validation result dot success. So now this guy will tell you, he can tell you why, but he doesn't just write it to the console window. And now this guy could, he can tell you. So if result is success, do that. Else if result is validation result dot needs uppercase, console dot write line. So now you can move that the interaction with the console window back out to here, I think, where it belongs a little better. You need at least one uppercase letter. I'm not going to write out all the cases there, but that's good enough. So now I can type in That is invalid. You need at least one uppercase letter. So now I can do A. I was actually expecting that to be too long. Oh yeah, okay, never mind. That makes sense. I do handle the too long here, but I don't handle too long right in here. That's the reason why. It doesn't tell me how many characters. Anyway, so if you want to do that sort of validation, there's several options in there, but none of that validation is strictly required for this challenge. At this point, I've been recording this video for well over an hour and a half, and we're only through those 5 challenges, and there's more to do. I didn't get to tic-tac-toe yet, which is the biggest one in this Catacombs of the class, but I think I need to stop for now because I got other things I need to do today, and this has just gone. This video has been by probably twice as long as the next longest one that we've done. So we'll wrap it up here and do the others soon, maybe next weekend. But that's the first 5 that are each making classes of different complexity, and hopefully that gives you some. Even if it's not, like I said, your approach may have been totally different, and that's fine. Again, like take the parts of this that you like, and the parts that you don't like, skip them. Don't feel bad if yours is different, because I think if you compared what I got here to the official, quote unquote, official answers on the website, I think you'd see some very wild differences there too. And that's the same person, the same challenge, doing it. Uh, Different solutions are totally legitimate. So, so yeah, like I said, don't feel bad if your answer is wildly different. Don't feel bad if you struggled, because these are tough challenges. But the hope is that it gets you sort of that hands-on feel for making classes that do something, because in short order we're going to be making classes that have to work together, and so to be able to work on a class and build it out and make sure it works well is a very important skill set. And like I said, it takes time and experience, and don't worry, you'll get there. Like, this is, we've all of us, any programmers, gone through this journey. It does take time. I think if you could go back and look at the first several classes that I wrote, you would say they're a total disaster. Um, but you do get there in time. So just be patient and just keep working at it. And like I said, look at how other people have solved stuff, and see what parts of how they did it you like, and take them, and the parts that you don't care for, skip them. Yeah, but we will wrap it up here. So thanks again for joining me in this video, and I will see you later.